These are the solutions to Mel Hom's Math 110C, Calc 3, Exam 1 at City College. Okay, number 1, you're given a center as negative 3, 1, 6. That automatically tells me it's going to be x plus 3 squared plus y minus 1 squared plus z minus 6 squared is equal to the radius squared. Get the radius, I just find the distance between these 2 points. Okay, so the distance between the 2 points is the square root of 4 minus a negative 3 squared plus 1 minus 1 squared plus negative 4 minus 6 squared. And this is going to be 7 squared, that's 0 squared, that's negative 10 squared. And that comes out to be 49 plus 0 plus 100, or radical 149. Square it, and you have 149. So x plus 3 squared plus y minus 1 squared plus z minus 6 squared equals 149. And raise it up there a little bit for you. Okay, number 2, unit vector. So just take the vector and divide it by its magnitude. Negative 8, 1, negative 6 divided by the square root of negative 8 squared plus 1 squared plus negative 6 squared. And that's radical 64 plus 1 plus 36. So the vector is negative 8, 1, negative 6 divided by square root of 101. Number 3, find the angle to the nearest degree between the 2 vectors. So cosine of theta is a dot b over norm A, norm b. A dot b is 1 times negative 4 is negative 4. 0 times anything is 0. 2 times 3 is 6, so the numerator is 2. Over the square root of 1 squared plus negative 3 squared plus 2 squared times the square root of negative 4 squared plus 0 squared plus 3 squared. Okay, so the top is 2. Bottom is radical 1 plus 9 plus 14, which is square root of 14. Bottom is 16 plus 0 plus 9, square root of 25. Okay, so that comes out to be 2 over 5 radical 14. That's cosine theta. Hit your inverse cosine button, and theta is about 84 degrees. Okay, number 4, find the direction cosines and direction angles. So the unit vector, okay, so it starts off pretty much the same as problem number 2, where you find a unit vector. So I take the vector negative 7, negative 3, 9, divided by its magnitude, 49 plus 9 plus 81, which is this thing squared plus this thing squared plus this thing squared. That comes out to be radical 139. So that means the cosine of alpha is negative 7 over radical 139. Cosine of beta is negative 3 over radical 139. Cosine gamma is 9 over radical 139. Hit inverse cosine of all these, and alpha, beta, and gamma are 126 degrees, 105 degrees, and 40 degrees to the nearest degree. Okay, 5, scalar and vector projections of B onto A. So for the scalar projection, comp of B, the projection of A, is A dot B divided by norm A. So dot product is 1 times 4 is 4, plus 1 times 2 is 2, plus 1 times 0 is 0, over square root of 4 squared is 16, plus 2 squared is 4, plus 0 squared is 0. So 6 over radical 20, which is 6 over 2 radical 5, 3 over radical 5. Vector projection, proj of BA is the answer that I got from before, 3 over radical 5, and then I multiply by unit vector in the direction of A. So I keep the same answer, 3 over radical 5, and then a unit vector in the direction of A is 4, 2, 0 divided by square root of 20, and this combination is 10, square root of 100. So it's 3/10, 4, 2, 0, and I get 1.2, 0.6, and 0. And I'm going to raise it up a little bit for you. Number 6, form the vectors PQ and PR. Since you got the origin, it makes it very easy. PQ is 1, 1, 1, PR is 4, 3, 7. Take the cross product, IJK, 1, 1, 1, 4, 3, 7. So I minus J plus K. So for I, it would be 7 minus 3. J would be 7 minus 4. And K is 3 minus 4. So that's 4, negative 3, negative 1. Okay, so the area of the triangle is 1/2 the magnitude of the cross product, right? Because the magnitude of the cross product gives you the area of the parallelogram. So 1/2 square root of 4 squared plus negative 3 squared plus negative 1 squared. So radical 26 over 2. 7, from 2, negative 1, 3 to 4, negative 2, 4. So the direction vector is delta x, delta y, delta z. 2, -1, -7. It's x2 minus x1, y2 minus y1, z2 minus z1. Okay, so r is r0 plus tv. So the vector 2, -1, 3, it's the same as the point 2, 1, -3, but write it as a vector. And then plus a scalar multiple of the direction vector 2, -1, -7. So that gives me x is 2 plus 2t, y equals -1 minus t, z is 3 minus 7t. Solve them all for t to get symmetric equations. T equals x minus 2 over 2 equals y plus 1 over -1 equals z minus 3 over -7. In -8, you have the point -2, -4, 1, and the normal vector is -1, -3, 2. The -1, -3, and 2 just become coefficients, and just put x plus 2, y plus 4, z minus 1, and clean up the algebra. X plus 3y minus 2z plus 16 equals 0. Number 9, the direction vectors are -6, 9, -3, and 2, -3, 2. They're not scalar multiples of each other. Okay, so you have to find a t and an s which works for all three of them. In this particular case, you can't do that. So I set the z's equal to each other. That's the easiest. Z is -3t. It's also 2s. So -3t equals 2s, which means s is -3/2 t. Okay, then I plugged into L2's equation. X equals 1 plus 2s, but s is -3/2 t. Okay, so that gives me 1 minus 3t, okay, and that has to equal -6t, equating the x coordinates. Okay, so that gives me 3t equals -1, t equals -1/3. Plug back in here, s is 1/2, but you get a contradiction. So if you plug in y equals 1 plus 9t, y is 1 plus 9 times -1/3, it comes out to be -2. But if you plug in y is 4 minus 3s, plug in the s value, you get 4 minus 3 times 1/2, which is not equal to -2. Okay, so that's a contradiction. That symbol means it's a contradiction. So that means they're skewed. Right, they're skewed. And finally, number 10, x equals 0, z equals y squared. That's like what used to be y equals x squared, parabola opening up. Y equals 0, z equals -x squared, parabola opening down. Z equals 0, then I get y squared minus x squared equals 0, x squared equals y squared, y is plus or minus x, and so you have lines going through the origins, slope of 1 and -1. And there we go. Okay, so this is the solution key to Calc 3, exam number 1.